Gentlemen, welcome back to the shop. I present to you the world's most expensive steel storage rack. The Austrian-made MCO Turn 140. This is a CNC lathe. Now, normally I would like to have this aged a little longer. It's been sitting in the shop dead for 2 years. And I've done, well, maybe 3 years now. I done killed it, but good. Actually, come to think of it, I've been in machine shops. This is probably the world's cheapest steel storage rack. And this video is just going to be an audit on this machine. I have been told by the expert, the self-proclaimed expert on these machines, and also the train guy or the train whisperer, just a nightmare to refit. So we're going to see. I like a challenge. We're going to have a look, see. But essentially, this is getting expedited because Philip in Thailand has one of these. He's got a production machine shop, and he needed a card out of here. So I'm going to see if I can get the card out of here, what for sending to him, because I don't need it. You know, I like, if I have no need for anything, I'll gladly send it along. Because of course it's a two-way street. Glenn from Gutter Protection Services had a DRO on his old milling machine, which he was kind enough to send me. I was gonna retrofit the Bridgeport, but then of course I got a Mazak Monster, so we're gonna put it on there after I audit the Mazak and get the drives going and all that. But first, Philip, this one's for you. This is a slant bed CNC lathe. You can see the bed there, and yeah, barely been used. Probably been crashed more times than it's been used. But I am expecting the best, meaning the worst, in German style engineering, you know, because we can. Probably 5-pole stepper motors, and I know the spindle drive is DC drive, and it controls, it's gonna be a nightmare. But anyway, let's have a look-see inside and see if we can get that board out for Philip. Right, we're in like sin. Look at this monstrosity. It's amazing that you can replace this with the desktop Mach 3 free software and a couple of Gecko stepper motor drivers. Right? Right? And we'll just turn this control around. You get a feel for the vintage. Yeah. You'll CRT monitor, cathode ray tube. Just the tactile, not even, oh, blister. Those feel like tactiles, but maybe not. And here's how you get the program in. Look at this, look at this. You're gonna love this. Tape drive. 1s and 0s on analog magnetic tape. Amazing. Let's see what program was this. COM data. Doesn't sound too interesting. It's a certified digital mini cassette, digital analog, Philips. We'll put that back in there. What for sending to the museum? There we go. And that's the control there, MCO-tronic T1, made in Österreich. Dirndl. Now before we get in there, we gotta make sure it's not turned on. Yeah, we're golden. And we're looking for an R, yeah, one of those, and I don't see it. However, I will show you what burnt right out of her. Where are you? Let the smoke out. Ah, right? No, right there. Yes, roasty, toasty. All through hole. Look at this, man. Holy. Man, there was a lot of work put into that. You know, surface mount looks like it's clean and real small, but it doesn't show you how much work actually goes into something like this. Like, look at this. You send a man to the moon with this thing. Actually, you could probably send me into low Earth orbit quite easily. And of course you say to yourself, well, she's already fucked. You can't fuck it anymore. Why don't you just replace that? Well, first, I don't know the value. And second, it wasn't this that failed. Something else failed that caused this to roast. This was just the weak link in the chain. So even if I replace that, I mean, look at all these bulgy capacitors, and yeah, it just, you could spend a month of Sundays going through this thing and still not turn apart. So rather than go and fix this Cold War era control system, we're going to go with new stuff that's well documented. That's Mach 3 and Gecko stepper drivers and all that sort of good stuff. I don't see any point in reinventing an old wheel. Like, why would I go back to a square wheel when we now have round? And despite being needlessly overcomplicated the way only Teutons can do, apologies, you know it's true. It still follows a typical control logic. So here's our input board here, or rather our power input board. Probably some rectification going on here just to drive the electronics. So this has got to be phase and shift and something something. So that's got to be the main board for getting power to the spindle. Oh, sorry about that. Got some worker bees going mental outside. The regular cart, so that's got to be controlling this spindle motor. Here's the stepper motor drives. Here's the brain box for the stepper motor. Here's the, what is this? Oh, data controller. Okay, so that's got to be reading from that thing and doing the G code. And the axis controller for the stepper motors to this guy. So this guy would talk to this guy talks to this guy sends pulses to that guy. Here, a video card, of course, to run the CRT, and machine and interface. That's what that is. Yeah. Look at this, control netc. So this must be Noternet control. You probably have, you know, hooked this into a mainframe or something. There's the CRT, old Mitsubishi CRT. Some scary looking caps. There's main contactor, big circuit breakers, big old fast blow fuses, maybe slow blow. But they're the type that won't explode on you when they do go. Now that is not a network control card, unless we're talking power network. Look at that cork stuffer. Mean looking, eh? Yeah, that's a power control card. Oh, and I found the board he was looking for. RD413001. So we got two of those. And it's gefrucht. Here's the spindle motor. It's a Baumüller in Nuremberg. This is a DC. I think it's shunt wound. But the way they do this is 400 volts DC, and then they just control the field winding to get the speed that you want. Am I going to make a DC controller that can do 400 volts? I don't think so. I don't think there's anything off the shelf. It'd all have to be custom made. So more than likely we'll use an AC drive with an inverter or a variable frequency drive and just mount it up. You know, we have the capability to machine the NEMA mounting, and we'll just buy some Lego parts and plock her on there, I imagine. Now for the tool changer, it looks like it's got a little motor, but it's got to be a stepper because there's no other way to get the correct position. There's a cog belt there. Got to be an oddball stepper, but look at the frame of it. Oopsie, look at the frame. Like nothing I've ever seen before. And that's a beautiful feature for such a small lathe, is this tool changer, auto tool changer here. Just rotates that head like so. Okay, now we got the two axes here, and you can see that super skookum ball screw. Look at the slides. I mean, mint. So we'll just have a look at that and then see if indeed it is some sort of oddball abortion of a stepper motor. We'll just get the frame size and swap them out. I mean, for the, you know, these projects are like time sucks. You could spend years dicking around with this. Well, I don't have years. So if I can trade some legal tender for expediency, then I will do that. Of course, that's why you do a machine audit. You figure out what you got. You sit down, plan it out, and see what makes the most sense. So I've been all around that little pallet changer motor with the boroscope and everything. I can't figure out what the hell it is, so I'm going to pop that cog belt off thing there, and then the 4 bolts, pull it right off. See if we can figure out what the hell it is. Okay, we got her. This is odd. It's a 3-phase motor, 380 volts. Now, how is it indexing that? Because it has to know when to stop, right? So the question is there a sensor in here, and this is electrical cable, or is this through coolant? Can you imagine if it's through, like on a little machine like that? That'd blow my fucking mind. But it could be. I'm gonna take it off and see. I don't see why they'd have a hose clamp though for for electrical conduit. That's kind of hokey. It's like peeling an onion, layer after stinky layer till there's nothing left but tears. We're coming around the mountain again to see that, trace that out, and there it is. It's that bottom one. So some sort of control, either chopper shaft or even maybe a momentary switch where it just hits a detent. So that's what controls that pallet changer thingy, or not, well, the tool changer. So now I'm just going to go through all the motors, all the control systems, figure out what I got, what I need, and yeah, perfect. Ugh, feck. Anyway, and then make a list, a short list. I sort of get a budget together and a timeline, long lead items, all that sort of stuff. And basically now it's just doing the research. And of course this thing was state of the art in, it doesn't say. There's the main drive motor. Let's see here, no. Oh yeah, there we go. 400 volts, 5.5 kilowatts main drive. 250 at 2500 RPMs. So obviously that's a DC motor, because AC would be 1750 or 3600, right? Well, now we come to it. I've exercised a little bit of Google foo, and I found a PDF for those stepper motors. They are 5-phase, so quick search, not much on 5-phase. A lot of guys trying to convert, well, you know, message boards, this and that, not having any luck, or not seeing any completed projects. So that tells me that's a big pain right in the cunning linguals. So stepper motors out. We're going to change them for bipolar, so 2-phase instead of 5-phase. Of course 5-phase is better. I mean, more is more better. That's just simple science. But less vibration, higher holding torque, all better for stop and go. But this isn't a production machine. This is just for shits and giggles mainly. I mean, CNC has been beat right to death, so why would I reinvent the wheel, you know? Gonna go bipolar and Gecko drives, you know, cheap, maybe Anaheim automation or automation direct steppers. So next step is to pull those stepper motors out. Now, the tool changer motor, 3-phase, that's gone. That's just on a bracket. So we'll change that over to, we could have a little DC servo, we could do anything, a little AC, you know, stupid little AC thing, turns off and on, and we got to see what the output of that sensor is for the positioning. That's no big deal. One thing I forgot was the coolant pump. Again, no big deal. We could put a 12-volt pump in there, no big deal. Now, where it gets interesting is this Baumüller-Nuremberg DC shunt motor. Now, this is a grunty unit. I mean, no lack of gravity in the thing. So the question is, do we pull it out right away and just use an AC with a variable frequency drive for the spindle motor? Or do we cobble something together and use that nice beefy motor? Now, I would not be adverse to using, you know, 3, maybe 2 or 3 different speeds. All, you know, optimized speed is for production. This is not a production machine. So what we could look at is just using 220 volts out of the wall, rectifying it, filtering it with some caps, and then sending it through some motor starter contacts just to control the armature. Now the armature is drawing maybe 30 amps, so if we put some current limiting resistors in there and then just run it that way, I can't see, you know, just dead nuts easy, and then the Mach 3 controller just ka-chunk, ka-chunk, turn on to this speed, turn on to that speed, turn off. I think it's worth having a go at that, and then if that doesn't work, then, well, we'll pull it off and put an AC motor on there, you know, no harm done. So in the cold, hard light of day, is it worth it? Absolutely not. But is it worth it as a hobby just for shits and giggles? Yeah, of course, I want to make my own CNC or convert my own CNC machine. The machine itself is solid, so why not have a machine that's going to last the rest of my life? You know, and I built most of it, so I'll know it inside and out. So I think that's pretty cool. And at the same time, we got that big old Mazak mill to go through. So, but that is another machinery audit altogether. Okay, thanks a lot for watching. Keep your dick in a vise.